So how do I get an approximate hypotenuse, but it actually can be an exact hypotenuse if you just keep correcting the error of it. So this is based upon rotation to angle 0. So if I've got a vector there, if I manage to rotate that to the 0 origin, then I've basically got the hypotenuse on a line to the axis. So then I have the hypotenuse explicitly at angle 0. So if I can get a vector and I can reduce it, I can rotate it to angle 0, then I can get the hypotenuse. So to do a rotate, you're not allowed to move in a straight line, you have to move in a circle. And that's why you wind up having to use square root to do it, or sine or cosine, or using all these complicated things on your calculator, which are not the foundation of the calculator. Those sine and cosine, moving in a curve, is a product of the other parts of the calculator which are more fundamental. So moving in a circle comes second, moving in a straight line comes first. So we're going to get there by moving in a straight line. So but it's true that if I was moving in a box-like pattern, then to correct this point to be angle 0, I just have to get this vector and face it sideways, and then that means hypotenuse equals x plus y. Okay, but then the thing is, I'm existing on this curve, not existing on the square. So that means there's so much error involved. But if I compose the error out of straight lines, then if I do, like, say 8 linear corrections, then I'll achieve moving on the curve instead of just on a straight line. So to get the first error of it, I do this. I go x take y. Now I have to explain this. Okay, so say if I'm on the curve here somewhere in this quadrangle, just say I'm there. Just say, now if this way is x and this way is y, if I go x take y, if x equals y, it would be 0. So if I was going straight up 45, x take y will now be 0. Okay, so, but if x doesn't equal x take y, the limits of it would be x take y. If x equals y, I'd be 0 in the middle. Or if it was up here, 100 take 0, I'd be if x was more, if y equaled 0, then x take y would be x. Or if x equals 0, it would be negative y if x equals 0. So if I go x take y from y equaling 0, x equaling 0, x equaling 0, y equaling 0, I get these limits out of it, these extents. So if you do a pre-sort and you sort that x is, if x is more than y, I go this way, or y is more than x, I go this way, and this way I go x take y, and this way I go y take x. I can sort of cross off this one, and I'm only ever x or 0. So if I'm only ever x or 0, that means I can go x take y as long as x is more than y. And then this does this thing called inversion. That means, see, if I go x take y, I'm actually getting 0 in the middle, and I'm getting x like on the larger one, and then this one's actually not in it because I sorted the points first. So then if I get that, then I can actually flip that to be the triangle I want if I go x, take y, because x is the limit. Because that's the same thing as going 1 take 1 equals 0, or 1 take 0 equals 1. Can you see how if that was my input, that was my output? I've done an inversion with subtract. So like subtract will do an inversion for you. Can you see how subtract is like swapping, going negative, like swapping polarities? So if I hit it to the opposite polarity, but you can see something, that this is actually negative and this is positive. Can you see how when I flip the content, I also flip the polarity? And if you're doing that in an electrical circuit, you're allowed to, but you can notice something, you actually flip polarities. When I go 1 take 1, I end up positive 0, or take 0 and a positive 1, you flip polarities when you do it. So if that was x take y, then I've achieved like that out of it, even though I have to do it with 2 separate subtractions. Then then all I have to do is take this halfway point instead. And then I can get 2 triangles, or I can get 4 triangles, or I can get 8 triangles, and the more triangles I add to it, the closer I get to actually moving in a curve. Okay, and so what does this do? Like, why is this more useful than any crap you read on the internet usually? It's because you've actually computed square root yourself without hitting the square root button on the calculator.